In this video, we will talk about optimization of the EIGRP protocol. So let's start with EIGRP query. That is a mechanism, guys, used by EIGRP to handle situations where a route becomes unreachable. Okay, so if the router loses access to any path and does not find a feasible successor for that path in the topology table, it queries its neighbors with the query information for that path. So the query packet contains information about the destination network for which the route was lost. And the router asking for the query is essentially seeking to find an alternate route to the destination. This route is called as an active router. So an active router is a router in EIGRP that is actively performing a route computation. Okay, so the limiting query packets in EIGRP protocol can help manage network stability and reduce the overhead associated with route recalculation. So EIGRP uses query packets to find alternate routes when a route becomes unavailable. However, the excessive querying can lead to increased network traffic and longer convergence times. So we can limit the query packets in EIGRP by using the route summarization, EIGRP summarization, and the EIGRP stop. So now if we have a look to this output that you are seeing here, okay, this router which this output was taken from is active for this subnet, and that is passive for this subnet. For 10390/24, this router is reaching already. Everything is good, life is good, the reachability is there, and there is no problem. Okay, P means passive router, no issues at all. On the other hand, for 10240 network, we have some problem, okay, because this router is in active state for that particular network, which means this router has lost connectivity to this 10240 network, and there's something bad going on about this network connectivity. So again, remember from previous slide, if you want to limit the EIGRP query packets, one of the method is EIGRP stop. In certain scenarios, you can configure routers as EIGRP stops to reduce the amount of routing information exchanged and limit the impact of queries. So stop routers only advertise a limited set of routes, which can reduce the query traffic sent to these routers. So this is useful for routers that do not need to participate in the full routing process. So stop configured routers do not forward routes learned by EIGRP to other neighbors, and more importantly, non-stop routers do not send any query message to the stop routers. So this saves bandwidth, okay? Let me try to explain you what is going on in reality, okay? So in this topology, I have 5 different routers. Router A, B, C, D, and let's call this one as router E. Router B has a connectivity to one of these segments, and this is 10180/24, okay? If router B somehow loses the connectivity for this segment, which is 10180/24, and if it doesn't have any feasible successor, then router B will start sending query message to its neighbors, and it will ask the other routers that, hey, router C, do you have any information about this network? I lost the connectivity. hey router D, hey router E. It will send query from here, and query from here. Then router C, D, and E will receive these query messages and will send query replies mentioning, hey, I'm sorry buddy, I don't have any information about this route. This is some sort of inefficient usage of the bandwidth, and there is lots of unnecessary packets going back and forth between the routers, because router C, router D, and router E is not connected to anywhere else in the network. Okay, so what I would do, I would go ahead and configure this router C, router D, and router E as stub routers, which means if this network goes down, router B will not send any sort of query packets for router C, D, and E. It will not go ahead and ask even if do you have any connectivity to this network, which doesn't make sense really already. By default, an EIGRP stub router shares certain types of routes with its neighbors, guys. Specifically, a stub router in EIGRP will share the connected routes. These are the directly connected networks on the stub router. These routes are shared to allow other EIGRP routers to know which networks are reachable through the stub router, and summary routes. And by default, a stub router will also share summary routes. Summary routes are aggregated routes that represent multiple subnets. However, for this to happen, you need to configure summary routes on this stub router. So if you do not configure any summary routes explicitly, the stub router will not advertise any summary routes. So you can override this setting. You can customize what a stub router can advertise by specifying the options with the EIGRP stub command. As you are seeing on the screen, we have EIGRP stub, and if you put the question mark, you will see all of these options here. So EIGRP stub connected only advertises the direct connected networks. Stub summary advertises summary routes. Stub static advertises static routes. And we have something called EIGRP stub receive only. This one only receives the updates but does not advertise any routes. Guys, there is something called EIGRP stuck in active. Okay, so when EIGRP routes are stuck in active, it means that EIGRP is unable to find a route to a particular destination, and the route computation is taking longer than expected. Okay, so this situation can lead to increased network traffic and the slower convergence times. So let's say one of the network went down again. Okay, for router 1, this network went down. So router 1 lost connectivity to here. So what would happen? Then router 1 will send some query message to its neighbors, right? So, hey router 2, do you have any information about this? Hey router 1, do you have any information about this network? I lost the connectivity. Okay. Then router 2 will take this query, check it out, and we'll see it doesn't have any connection to that network. Then router 2 will also ask its neighbors about this network. Hey router 5, do you have any information about this network? And hey router 4, do you have any information about this network? Okay, so what will happen generally, these routers, router 4, 5, 6, 7, 3, 2, will get back with a reply packet. Okay, reply, and another reply will be sent to router 2. Okay, router 2 will have this reply packet and it will send to router 1, and they will mention, we are sorry, there is no connectivity for this network that you are querying. Okay, but in some cases, things might be worse even. Okay, so let's say I sent this query message to router 2 and router 2 sent this to router 5, router 4. Okay, then router 4 and router 5 will send these replies to router 2, right? So by the way, in EIGRP, by default, a router will wait for 3 minutes to have a reply for a query. Please keep in mind. Okay, so these reply packets can reach to router 2, but somehow, maybe because of a CPU issue with the router 2, or maybe because of a network congestion, these reply packets might not be forwarded to router 1. Okay, so these reply packets, consider a scenario, these reply packets are dropped at this point. Okay, then what will happen? Router 2 won't be able to send a packet back, a reply packet back to router 1 within 3 minutes, which is the default one. After 3 minutes, router 1 will think that, hey buddy, there is no response coming back from your side, even for my simple query message. It has been 3 minutes. I am assuming now you are down, and it will go ahead and destroy the neighborship with router 2. Oh, that is a very bad situation, right? So this process is known as EIGRP stuck inactive, which means the router sent a query but have not received any reply packet and started to destroy the neighborship with other routers. So after Cisco iOS, I believe 12, Cisco made a modification to this behavior. Okay, so what they did really, let's say router 1 sent a query and query came router 5 and 4 from router 2 and they sent a reply and somehow this reply is blocked. Then they introduced something like SIA query packet. Okay, SIA query packet. If router 1 does not hear back a reply from router 2, this time within 90 seconds, it will send a message to router 2 that is an SIA query packet, and it will mention like, hey router 2, I have sent you some query packets but I didn't hear back from you. Okay, what is going on really? Then router 2 can go ahead and reply router 1, hey bro, I'm sorry, even for myself I didn't have any reply packets from router 5 and router 4. The reply packet seems to be dropped on the way or something like. So that is why it will send an SIA reply packet, and that because of this reply packet, router 1 will not go ahead and destroy the neighborship with the router 2. Alright, we have something called EIGRP Auto Summarization. That is a feature, guys, in EIGRP that automatically summarizes the routes at classful boundaries. This means that EIGRP will create summary routes for contiguous subnets that fall within the major network class, class A, class B, or class C, to reduce the size of routing tables and the amount of routing information exchanged between routers. Okay, so this behavior is disabled after Cisco iOS version 15 and can manually be disabled with the no auto summary command as well. So how I am verifying if my EIGRP router is performing auto summarization or not is by using show IP protocols command, and you will be able to see there's a section for automatic summarization and it will be showing like if it is enabled or not. EIGRP manual summarization allows you to create specific summary routes to reduce the size of routing tables and improve the efficiency. This is done by aggregating multiple smaller routes into a larger summarized route. So manual summarization gives you more control compared to auto summarization, which operates at classful boundaries. Okay, so in here you are seeing we have, let me grab my pen. So we have like 4 different networks connected to the router 1, and I am going ahead and performing a manual summarization, which is 10.20.00/14. Pay attention to the subnet mask, it is not a classful one, and I am representing these 4 different networks by using this single IP and the subnet mask. Okay, so maybe you are thinking, guys, why really auto summarization is an issue? Let me show you. Okay, let's say this router 1 is connected to one segment and it is 172.16.10.0/24. And let's say this router 2 is also connected to a segment and that is 172.16.20.0/24. Is it possible? Yes, perfectly possible, because the network IDs are very much different for this and this one. Okay, so if both router 1 and router 2 would be performing EIGRP auto summarization, router 1 would advertise this network as /16 to router 2. On the same way, router 2 would advertise this network as 172.16.00/16 again. That is a big issue, guys. Okay, so router 1 is saying this network is with me. On the other hand, router 2 is saying no, this network is with me. So that is a big deal. That is a big issue. So to prevent this one, mostly we need to go with the manual summarization option. So how I'm doing the EIGRP manual summarization config, I'm going into the interface mode. For example, let's say I'm doing it for router 1. On the interface mode, interface gig 00, which is this interface, I am typing IP summary address EIGRP and the EIGRP autonomous system. Then I am typing the network as I am trying to summarize. Okay, 10.20.00 with the subnet mask of /14. This is how I am doing the summarization. EIGRP can also perform the load balancing. Okay, so EIGRP load balancing allows a router to distribute outbound traffic across multiple paths to the same destination to enhance the network efficiency as well as the redundancy. So EIGRP, guys, supports both equal cost and the unequal cost load balancing. So by default, you can load balance up to 4 equal paths, and only the feasible successor paths can be used in load balancing to make sure there are no loops in paths in EIGRP. So how I am doing the configuration, that is pretty much basic. So I'm going in, so for example, if the BB router, which is this one, wants to use unequal load balancing to access 10.1.20/24 network, the command is pretty basic, guys. So I'm going to the router EIGRP and I'm typing the autonomous system number, and the command is variance, really, variance 2. Okay, that means I will send 2 packets from one path and only 1 packet from the other path for load balancing purpose. To verify EIGRP load balancing, I can use show IP route command, and here you will be able to see the network which is reachable from multiple different interfaces and different next hops with the same AD and with the different metrics. Alright, we are coming to end of this session as well, and thank you so much for joining me, guys.